So this is part of the homework for the first homework there. Probability predictions is where we're going to start. Then we'll go on to the other side, which is a little bit different. So if you flipped a coin 50 times and got heads 23 times, what is the experimental probability of getting a head? Write your answers with fraction, decimal, and percent. There we go. So they got 23 heads out of 50. There's our fraction. But we do need the decimal, which would be the same as 23 divided by 50, which is 0.46. Then we multiply that by 100 to get the percent, and 46%. All right, if you flip the coin 100 times, how many heads would you expect to get? This is not based on the experiment from number 1. This is based on a new answer. So, well, the heads is 1 out of 2 possible outcomes for any coin. So out of 100, yeah, this would have to be 50 out of 100. Now a coin is tossed 20 times. It lands on heads 9 times. What is the probability of heads according to your experiment? That'd be 9 out of 20. That's a 9. Write your answers a fraction, decimal, and percent. So we're going to do 9 divided by good old 20, which is 0.45, which has a percent. Multiply that by 100, 45%. Number 4, you're a teacher in 7th grade math class and you want to create an experiment for your class with red, yellow, and purple marbles. You want the theoretical probability of drawing a red marble to be 1/2, the theoretical probability of drawing a yeller to be 1/3, and the theoretical probability of drawing a purple to be 1/6. If you want a total of 1,260 marbles in the bag, how many red marbles are you going to put in the bag? Well, the reds are the easiest, right, because it's half. Half of the 1,260, which would be 630 marbles. Well, yellers was 1/3 of that. So for good old yellers, we're going to just take that 1,260, and 1/3 of those will be yellers. So that appears to be 420 yellers. We want the probability to be 1/3, so a 1/3 of the marbles have to be yeller, and in this case there's 1,260. So 1,260, 1/3 divided by 3 there, and you get 420 marbles. Next up we got purple. 1/6 of them are going to be purple in this case. So that's because it's a theoretical probability of 1/6. So that appears to be 210 purple marbles. Now, if that's all the colors that we had in the bag, and we added these, we could see also that you'd get 1,260 total marbles, which is what we wanted up there, is 1,260 marbles in the bag. So this number 4 has a lot of different answers. We just have to decide to make the marble experiment a little bit more difficult, except for just for the purposes of safety. Yeah, we're going to reduce this down to 1, 2, 3, 4, 5 colors instead of that awful other one. So we'll just figure out at these. Now I did say that we want 400 marbles, right? Now I did say we do not want more than 2 colors to have the same probability, so we got to make sure they're different. Now we've only got these 4 in there though, so we got to be careful with the values that we use. For example, maybe for red I would want 1/4 of them to be red, and for green maybe what you want is something like 1/5. Okay.
Where's your A?
And then for old yeller, we got half of those marbles are yeller, Well, if there's 400 marbles, then half of it would be
60.
200. And if 1 out of 5 marbles are green, then it appears that you would have how many green marbles?
80.
Looks like 80. And if a fourth of them are red,
35.
then it appears that you would get 100 right account. Poiples, what fraction should be poiples?
140.
All right, we got to go with something really small because that's about all that we have left. I'm going to use a 40th right account, which would have given us 10 marbles.
Oh, it's not pink.
Now the reason we had that is because there is another color pink, but we're not actually going to figure out how many pinks we want. So we'll just remember that when we add these up, it can't be more than 400, right? And right now we have 390. And if this were the case, then how many pinks would there be?
140.
That'd be 10, 1/40th or 10 total marbles. All right, answer the following without using a calculator. Determine which fraction is bigger in each pair. Justify your answer with pictures or words. Well, 1/2. Halves are bigger pieces than thirds. So this one would have to be a less than. 1/3 is less than 1/2.
Yeah.
3/7. Sevenths are smaller pieces than fifths. So this one also would be less than 3/7. Like if you were looking for the amount of food or bacon, would you want 3/7 bacons or 3/5? 3/5 because it's bigger bacons. All right, so ordering these from least to greatest. So starting with the number farthest to the left is the third. Next up is 2/5. Next up would be the 1/2. And then finally the 3/5. Right up and down. Any questions? Turn it off. This one, number one, for some of us it may take a little bit of time on these. Find all the possible outcomes of flipping a coin, heads or tails, 4 times. In other words, how many different ways are there to get heads and or tails in 4 flips.
Do I have a coin?
So let's consider several of the options up and count. And we'll make a list of all the possible options that we have. First up, on the first flip you could get heads, perhaps. Maybe on the second toss you get heads. Perhaps on the third toss you get heads. And then finally on the fourth toss you get heads. That is one possible outcome for these. Well, let's say that I toss heads on the first one, heads on the second, heads on the third. Then I would need tails on that last one because I've already looked at heads. Now that's 2 possible outcomes for these. Let's continue. If I get heads on the first, heads on the second, maybe I could get tails on the third, but then heads on the fourth.
I thought heads, tails, tails.
If I get heads on the first, I could get heads on the second, and then tails on the third, and then tails on the second one. You guys hopefully you're noticing a pattern on these
Yeah.
as we continue this process.
What if
So let's go ahead and write them all in. So this gets us halfway there because I've got heads on the first one for each. And that's all the possibilities we have for heads on the first one. The next up is to get tails on the first one. And then the final one is tails, 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 tails. 16 possible outcomes. In other words, how many different ways are there? Bam, we got it. 16. Now, if you guys remember this, you guys think that 16 is a lot. Remember when we did the dice with the racing horse stuff?
There was like,
We got 36
Yeah.
on that. That was a lot more listingness. So it's a little bit different, I guess, because there's a lot more letters to write on these.
the
All right.
chance of that was like 1 out of
Based on number one, what is the theoretical probability you get heads on all 4 flips? Well, I only see one outcome that has that. 1 out of the 16. What about the heads on all 4 flips? On at least one flip. So heads on at least one flip. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So there's 15 of these that have heads, at least one heads, out of the 16. Another way we could look at this backwards would be that there's only one of these, only one has no heads at all. And so subtract the 1 from 16, you got 15 out of 16. Get heads exactly 3 times in 4 flips. Now notice it did not specify how many in a row we needed, just that you get 3 heads exactly in the 4 flips. So the first one doesn't count because it's 4 heads. It wants just 3. So there's 1, 2, 3, 4. I only got 4. 4 out of the 16 have exactly 3 heads. And yeah, you could simplify that to a 4th if you wanted to. Alright, so just so you guys understand, it may be helpful to change these into decimals. So this would be 1.2 radian. This one is 0.3. 1/5 is 0.2. And 3 halves is 1.5. So starting with our 1.2, that would be approximately radian. And that was 6/5. 0.3 would be just above that 0.25 radian, and that is 3/10. 0.2 is just below it, about radian, and that is 1/5. And then finally, the 3 halves at 1.5, which would be radian.
I already did this one.
3 halves. So we did all the graphing. Now to list these in order, starting with the one farthest to the left, that is 1/5. Next up is the 3/10. Next up is the 6/5. And then the farthest to the right is the 3/2. We'll just put commas between those. And now they're listed from leastest to greatest.